Yes, good morning to all. Yesterday we discussed about that what is acceleration. That is a rate of change of velocity is called as acceleration. Its SI unit is meter per second square. Remember that SI unit is meter per second square. The formula of acceleration is A is equal to V minus U upon T. That is V means initial final velocity, U means initial velocity, T time taken, A means acceleration. SI unit is meter per second square. This is the SI unit of acceleration. And then different types of graph formation: uniform speed, non-uniform speed, and then uniform velocity, non-uniform velocity, uniform acceleration, non-uniform accelerator, retardation, the uniform retardation acceleration, non-uniform retardation acceleration. The graph we discussed. One more graph is there. This is about the t time taken, and then here with the distance take. If this, if draw like this, it means that object become in a station at rest. Okay, the object is at a rest. This if graph shown. Okay, today we discussed about that equations of motion. Today we discussed what? Equations of motion. There are main three equations of motions. Very important is this. It helps to do the numericals. That is v is equal to u plus at. V is equal to u plus at. This is the first equation. That v means final velocity, u means initial velocity, a means acceleration, t means time. Okay, next second equation is that s is equal to ut plus half at square. S is equal to ut plus half at square. Means s means you know that distance, u means initial velocity, t means time taken, and a means acceleration, and t means again time taken. Okay, this is that second. And the third is 2as is equal to v square minus u square. This is the third equation of motion. So a means acceleration, s means distance, v means velocity, that is final velocity, and u means initial velocity. These are the three equations of motion, which is very important. And how does it is derived? To show that derivations, we use that graphical method. Okay, first we go to that formation of, that is equation first, that's v is equal to u plus at by graphical method. Important, this one is very important. First you draw the graph. This is x-axis. X-axis was the time taken, we taken here t as in, and the y-axis we taken as a velocity, that's meter per second. The velocity is yeah, say unit is meter per second. Okay, it's point O, and from point O to A, initial velocity is there. This point A, considered point A, and from point O to A is a stationary, and then again an object is moves with the velocity from A point to B point. Okay, that from O to A, what is this? Initial velocity. That's at a rest. Okay, it is in rest. We initial velocity is denoted by small u. Then again that A object moves at a distance, so B point. Okay, we called as a B point. This one is called. Again we has draw a line, perpendicular line, So what is this point with in that t time, that point is called as a, in x-axis another point is formation, that is C point. Okay, so OC is, what is that, it shows the time taken, and AB shows that, that is AB shows that what, AB shows that velocity, change in velocity. Okay, so from point A to B, that velocity goes on changing, so that's B to point, B to A point, what is shows the change in velocity. Okay, first you draw this like this. Next you write down that all that from point A to B, that change in velocity happen, that is we are taken as a, this as a change in velocity. So it is a final velocity and this one is a initial velocity. So now you start to derive it. That's, let us draw AD parallel to OC. So let us say draw OC parallel. So OC parallel to this point is called as a D point, AD. Okay, why we draw it? Because that velocity is change here now. That's why we are drawing parallel to that OC. Okay. Next, we go to that what we see in observe the graph. From the graph, so what's the velocity changes here? BC. The velocity changes here, BC. So what we can write as a BC, so that is BC is equal to what we write? BC is equal to BD plus CD. BD plus CD or DC. BD plus DC. Okay, we can write here totally BC. What can we write here? BD. We are just part it. BD plus DC. Total what is BC? Okay, this one. Now again BC is equal to BD plus, what can we write here? DC. Instead of DC, what can we write here? See opposite sides. So that is OA, which is equal now. The opposite sides also same distance is covered. Instead of write with DC, what we write here? AO. AO. Because AO shows what? Initial velocity. So by substituting we get, by substituting. So what is BC? BC means what? V. That's final velocity. It shows V. BC means V. So now next, what is OA? Yeah, AO. OA, yeah, AO. What is OA? It is a initial velocity. This one is the equation number 1. By now we substituting in equation number 1. So what we get? BC means, that is V. BC means we are substituting now. That's V. BC, in place of BC, what we write? V. And as it is, we write BD plus, what is that? OA, yeah, AO. What is that substitute we have? U. So U. And then we are put that in LHS BD. That's BD is equal to what with V. We shifting the U here. That is V minus U. Okay, this one is the, remember that this is an equation number 2. Okay, BD is equal to V minus U. This is the term, equation number 2 we get by substituting. Okay, next we go to that clear it. Next we go to that point from the velocity time graph. From the graph, what we, the acceleration, what is that acceleration show? That is change in velocity. You know that what is the formula of acceleration? A is equal to change in velocity with respect to time taken. So what is that change in velocity? By seeing that graph, the change in velocity, how much the change in velocity, that is BD is change in velocity. See here, from point A to B, how much that is BD change in velocity. The time taken is how much? AD. That is time taken is AD. Okay, that velocity change is BD and the time taken is AD. Okay, so what we write here now, that is BD upon AD. A is equal to, what is what can we write AD? So see again the graph, you see AD which is parallel to that OC, which is parallel to that OC. Okay, so that is OC. By now we substituting OC. What is OC? By you just always see that graph. What is OC? Shows that OC shows time taken. OC shows time taken. So that is in place of OC, what we substitute, that is T. The acceleration is equal to BD upon time taken, T. So we know that what is BD now? Cross multiplied. BD cross multiply, that is 80. BD is equal to 80. Okay, remember this point, that is BD is equal to what? 80, which is used in the next equation also. BD directly I used in the next equation, derivation of next equation. So remember that BD is equal to 80. Now substitute in equation BD, that is substitute in equation number 2. Okay, so you know that what is that equation number 2 is BD is equal to V minus U. BD is equal to V minus U. This is that equation number 2. So what is BD? We substitute here that BD. Substitute BD in equation number 2. So what is that BD is? BD which is equal to 80. That is 80 is equal to V minus U. Okay, last step is, so we taken as a T as in a upon, that's A is equal to, or we shifted that U here. Okay, so that is 80 is equal to 80, we shift U here, then is equal to is there, transferring that U, that minus is should change into a plus, that is 80 plus U is equal to V. Okay, so now V is equal to, we write V is equal to U plus 80. This is the derivation of first equation, which is most important. All this topic, 3 derivation is very important, which is asked in that examination. Derive that equations by graphical method were asked. You first draw the diagram, then you write like this, that is, let us say draw AD parallel to OC. You show all the things, that is initial velocity, this is final velocity, and then you from the graph what we get, BC is equal to, what can we write, BD plus DC. So BC is equal to BD plus, which is DC, which is equal to that OA or AO. So that is, we write here AO or OA. Now we substitute BC. What is BC? Totally final velocity, the change in velocity is V, that is V. BC is equal to V. OA is equal to initial velocity, so V is equal to BD plus, by substituting BC means what, V, so we are substituting V is equal to BD plus U. That's now equation number 2. This then again from the velocity time graph, that we get acceleration is A is equal to change in velocity upon time taken. By observing the graph, A is equal to how much that changing velocity, BD, and time taken is AD. But you know that AD which is equal to OC, because parallel to each other, that's why AD is equal to OC. So now here instead of AD we write here OC. By substituting OC, which OC is equal to T. You know that OC by graph, you know that OC shows that's point O is here O, here C is C. So this is time taken, this shows we are substituting T. So then A is equal to BD upon, in place of OC what we write, T. Now cross multiplied, BD is equal to AT. Substituting in equation number 2. Okay, BD, substitute BD in equation number 2. What is the equation number 2 is? BD is equal to V minus U. Okay, this is equation number 2. Then we substituting that BD is equal to AT. AT is equal to V minus U. By transferring that U in this side, so it become plus, minus is equal to, that become a plus, because AT plus U is equal to V. Then we write, this is the derivation of first equations. Okay, equation of motion, this first equation, which is most important. Next in class we discussed the graphical representation of second equation and the third equation, and then what is the circular uniform motion. Okay, and then we do some numericals also. Okay, and you learn properly this topic. Okay, thank you.